Hello everybody, I'd like to give you a little tutorial, a little 101 crash course on how alternating current works for those of you who have watched video after video after video of people claiming to know how it works and trying to explain it. I've watched many of them, and I have yet to see one that really grasp the concept of what it means, because my confusion came from the difference between direct current and alternating current, in the sense of if electricity runs positive to negative, then where is the positive and negative in alternating current? Because if you ask an electrician or anybody that's seasoned in the field, they'll say, well, there's no positive or negative in alternating current because it alternates. Okay, well what do you mean there's no positive and negative? How does that work? Well, just that we say 0 and 180 degrees. What the hell does that mean? Well, I'll explain it to you. Here you go. I'm gonna draw it on paper and make it real simple. So this hopefully it'll be pretty short and pretty simple. It's just gonna be the basics of just what the difference between alternating current and direct current. So direct current, have a battery like in your car. It's got 2 posts on it. One's positive, one's negative. Okay, and then you got a cable that runs to all the circuitry that's in your car or whatever, or if it's just a regular battery for a flashlight or something, it's just be like one little loop, and the return path is, once it goes through all the circuitry and everything, it comes back to the other side and goes to negative. And as far as like the new theory that or they've discovered whatever, that electrons don't really flow through wires, it's the electric field that's created. Anyway, but don't worry about that right now. We'll talk about that later. But for right now, just for all intents and purposes, just assume there's electrons flowing through the wire, and it goes from positive to negative, even though first it was positive to negative, then it was they flowed negative to positive, then it was they don't flow at all. It's an electric field created. So I don't think they'll ever be able to make up their mind what it is. But anyway, the difference between this and alternating current is, and by the way, yes, there is a positive and negative in alternating current. It's just there is no positive connection or a negative connection that can be made in alternating current, but there is a positive and negative field that's created. It just flows in both directions. So the reason why they call it alternating current is, number one, because it flows back and forth, like think of a chainsaw, okay, and it's got a chain on it that's on the end. This is where all your teeth and shit. This is crude drawing, but anyway, and the chain runs in one direction, okay, so and all the way around, and comes back to the other side, but it continues to flow in the same direction. Okay, now take that same chain, okay, and instead of it flowing in one direction, have it set up so that it moves. So like put one hand on this side of the chain, you know what I mean, and grab a hold of the chain with your hand, all right, and then take your other hand and put it on this side of the chain, all right, and grab that side of the chain, and then move your hands back and forth like you're sawing a piece of wood, okay, and then the chain, as it moves back and forth, as you move your hands back and forth, that's alternating current, okay. And then how they convert that into direct current for devices in the house and whatnot, is they take the forward direction, right, and it like, say it like turns a motor or something, right, okay, and the motor rotates in one direction, okay, but then think of a ratchet wrench, okay, that you're turning wrenches under the hood of your car with, right, and as you're like turning the wrench back and forth, one way it clicks like and then you turn it back the other way, and that's where you get your torque from, okay, where it actually turns the bolt, and then you push it back the other way, and it's and you don't get any motion that way, but then you turn it back the other way, and that's where and then the bolt turns again. So it's this constant back and forth, and the bolt only turns a little bit at a time, step by step, okay, and that's how how you continue something in the same direction when the force is moving in both directions, back and forth. And that's why when you look at like power inverter or AC adapters and whatnot that you plug into your wall, it'll show a line over the top, and then on the negative side it'll show these little lines that have breaks in them. Okay, that's because it's moving from positive to negative, but it's, as the positive's moving constant, the negative side is ratcheting, kind of, you know what I'm saying? So you're only getting that you know what I mean? And the reverse direction doesn't get used. It just flows back, and what they'll do is they'll send it through capacitors. And so it does get used. It goes through a capacitor, and it gets stored when it goes the other direction. And then when the pole flips and goes back the other direction, then the capacitor releases its energy at the same time. So then you get the power from the negative direction and the positive flowing at the same time, but in pulses. So when it flows one way, it's going with the flow of the current, and then when the current flows back the other direction, it stores in a capacitor, and then flips again, goes back the other direction, and the capacitor and the current from the line gets released at the same time, and that applies so you get the entirety of the power. But it just goes in pulses. All right. So anyway, but then how it's produced is at the power plant. You have one magnet, all right, and now they can layer generators so that you can have one magnet that will induce current on multiple coils, more than just 3 coils. And it'll go in steps, so they can actually, you can get probably 6 or more phases out of one generator. But then how it's applied is that it's like some of the phases will be again placed in capacitors, and then they're aligned with the phases of the 3 phases of the primary coils. So that so the capacitor will release into those three primary coils, and that way it keeps 3 phases of electricity flowing at all times, no matter how many phases are actually created with the generator. So anyway, but you have a magnet that's north and south, right? And it's just one, okay, and you have 3 iron cores with copper windings around them, okay, and then there's another iron core with copper winding around it, right, and then there's another iron core with a copper winding around it, okay. And so as the steam turbine that's direct driven to the magnet, which is the rotor, as it turns in one direction only, clockwise, and then in the southern hemisphere it would be counterclockwise, because of the Coriolis effect. You have to do some research on your own to understand the Coriolis effect, but that's why hurricanes spin in one direction in the northern hemisphere and in another direction, and the same thing while you flush your toilet here and it goes clockwise, but then in the southern hemisphere you flush your toilet and it goes counterclockwise. Now again, when I say that, it's relative to whoever it is flushing the toilet in whatever locale they're in. If they're in the southern hemisphere and they flush their toilet, relative to them it's going to be clockwise. But then when we flush our toilet up here, relative to people in the southern hemisphere, our toilet would be counterclockwise. So, if you're in the northern hemisphere, it's clockwise. If you're in the southern hemisphere, it's counterclockwise. But if you're in the southern hemisphere, and viewing a toilet, in the northern hemisphere, it's going to appear to be counterclockwise to you. Anyway, but that's trailing off the subject. Anyway, so your magnet turns in the generator, and as the north pole, which the magnetic field lines will flow in one direction, which is south to north, or rather north to south. So it flows outwards from north, like so, okay, and down towards the south pole and back in and then back out again, just one continuous loop, right? And as this magnet rotates, when north is aligned with the coil, the iron core and coil, okay, it's gonna push electrons in the same manner out north and then back towards south, okay, and then back in again, right? And this outward flow towards the north is going to excite the electrons in the coil and make them flow that direction on the conduit, which is the copper wire. So it's going to flow outwards on the copper wire like this, and then that copper wire or aluminum or whatever it is, will go through your high tension power lines and all that down to your distribution centers or your substations and whatnot. And after it goes through all that and and reaches your house and then to the return line and then back to the power plant, which you're talking about stretching miles and miles of wire, and then it comes all the way back from all that and then back to the end of the circuit, which is the other end of the coil. Okay, so in one way it's flowing in that direction, okay, and then this north pole, once it passes that, then it aligns with your second coil and excites the electrons, and again they flow outward from north to south, right? But they stay on the conduit, so as it's going through the conduit, which is the copper wire, they flow in the direction of the copper wire. All right, and then it goes all the way out through the substations and all this and and comes all the way back to the to the return, which is the other end of the coil, which is on the south pole. Okay, and then again, once it passes that and gets to the third coil, same thing. It excites the electrons and flows with the magnetic field from north to south, and the electrons stay on the conduit and flow on the conduit in the direction of north, and all the way out and all the way back to the return, which is the other side of the coil. Okay, so now that's when it's aligned north. Now what happens is that when north is aligned and then it passes heading towards the other coils, south is coming back around as well, and eventually you'll get to the point where the south pole of the magnet is then aligned with the coil rather than the north. And when that happens, then because it stays with the polarity, so then north is facing the other direction, in which case now the coil, when it excites the electrons, instead of flowing this direction where it was to begin with, now it's going to flow the other direction, which is aligned again, north facing this direction now and south facing the other direction. So then it's going to be north is going to be going out this way and coming back in this way. And when it does that, it's going to excite the electrons on the conduit or the conductor, which is the copper wire or aluminum, whatever, and it's going to now reverse the flow and come back this direction. And then again, it's going to be sent out from, the side that is aligned with north. And it's going to go all the way out through the, substations and everything, through your house and all that. And it's going to hit the return line, and it's going to come all the way back into this side. So that's why when it's aligned north this way, they flow out this way and back. And then when the magnet rotates back 180 degrees from the coil, now it's aligned the other direction, where north is facing this way and flows out that way and all the way back. So that's where you get the back and the forth and the back and the forth. Every time the magnet rotates 180 degrees. So when it's north-south this way, and then south-north, north-south this way, and then north-south this way, and then north-south this way. And as it does it, the electricity flows this way, and then back this way, and then this way, and then back this way. Okay, and then the same thing with the next coil, as it comes around, it's north and south this way, north and south this way. It's going to flow back and forth, back and forth. And the whole time, this rotor is spinning in one direction as it does this. And this is why, so you have 3 coils, right? And that's why you have 3 phases, right? You have 1, 2, and 3. And because of the way that they're set up, these coils are set up, they're aligned 120 degrees apart from each other. So from this coil to this coil, right, the distance between the two is 120 degrees on a circle, okay? And then again, this from this coil to this coil is also 120 degrees, okay? And then from this coil to this coil is also 120 degrees, okay? And when you add all 3 120 degree separations together, okay, you get, I'm sure y'all are good at math, you get 360 degrees, okay? So, and that's one complete rotation of a circle. So, but now, why do they say 0 and 180? Okay, when they're talking about alternating current, they say 0 degrees or 180 degrees. Okay, that's because on one phase, which is just one coil, okay, and when north and south line one direction, that's 0 degrees, and then when the magnet goes all the way, to the other side, where north is now this way and south is the other way, it's 180 degrees out from 0, which is where it started at. So it's at 0 when it's lined this way. It's at 180 degrees when it's lined this way. So that's the distance of separation between north and south alignment on one phase or one coil. Okay, and then the same thing with the next phase in the next coil. When it's north-south line one way and north-south line the other way, they're 180 degrees apart from each other. Okay, and the same thing on the third one. So you have 120 degrees of separation between each phase, which is each coil, and then you have 180 degrees of separation between the polarity difference in its motion. So there you have the 0 and 180 when they're talking about alternating current. Okay, now the positive and negative that does exist. Okay, again, it's not in the sense of one direction, positive and negative. It's just that when it's aligned north and south this way, okay, and then vice versa, when north is now this way and south is this way, okay, this is positive and this is negative, okay, and then in the same sense, this is positive and then this is negative. So the positive and negative are oscillating back and forth 60 times a second. So when it's placed on a conductor, okay, the electricity it's not moving in one direction the whole time. it's just moving back and forth like a seesaw. Okay, so the electrons, if they did move through a conduit, in this case, they actually would not fully complete the whole circuit from beginning to end in its travels. It only goes a little ways this way, and then it turns right around and comes back a little bit this way. It'd be like you walking out your front door, getting down the steps, and then turning around and coming right back, and then doing that 60 times a second. So that's why they don't use positive and negative when they're talking about alternating current circuits or AC circuits. Let's see. Now, when we're talking about the 120 degrees apart from each other, when you have three phases of electricity, because you look at each phase separately, but because they're all within the same generator, all three phases. Okay, that's why they call it a three-phase generator, or a three-phase motor, which is just the reverse of a generator. Okay, so when it's in motion, you have one phase that, because it's alternating, it makes this this sine wave, which is a serpentine pattern. Okay, and this is just a two-dimensional representation of the actual motion. The actual motion spirals like this. Okay, that's the three-dimensional representation of the sine wave, where here is 0 degrees, okay, which is when the magnet is aligned in this direction, okay, and then you'll have the magnet when it's aligned in this direction, okay, which is just offset, right, which would be like 45 degrees, or in the case it'll be 0, and then 0, 45, and then when it reaches that would be perpendicular, and then this would be I forget what the word is for that, but anyway, it's 90 degrees in this position from where it started, and then when it makes its full 180 degree rotation, there you have 0, and then 180 here, okay, and then you come back over here, and it's now in this position, or well, let's see, yeah, now it's in this position, or whatever, you get what I'm saying. Then it's 45 degrees again, and then here's 90 again, and then here's 45 again, and then here's 0. Okay, now 0 can actually be considered 360 as well. Okay, so and then 90 can be, let's see, so if you had 0 to 90 to 180 plus plus 90 again would be 8, so 260 to 270, I guess. I'm not good at math. I fucking suck at it. I have trouble doing it in my head. I mean, I know math, but I can't just like think in my head what it is. But so 8 and 8, 16, so 17. So yeah, 270 degrees, and then 360 degrees is the last. And then you have 0, 45, 90, and then so 9, 10, 11, 12, 13, so what, 135, I guess, and then you have 180, and then 80, 90, 110, 20, 2500, so 225, I guess, and anyway, just keep going until you get to 360. But they just say 0, 180, and then 120 degrees apart when you're talking about the different phases. So on a sine wave, and they do it in two dimensions because it's just easier to represent in that manner. But when each phase is being represented on like an oscilloscope or whatever, each phase being 120 degrees apart from each other is represented by multiple sine waves layered on each other. And every third. I got my door open, freaking mosquitoes are eating my ass alive. Anyway, so there's your third phase, and that's how it works. So and then when they talk about see, I wish I had a little more uniform than this, but you can see that each spot where it intersects, is you get this like downward slope. So when you're making, motors work great with these, when you're just using, 3 phases alone, and it's a 3-phase motor, then you don't need capacitors to help the motor spin, because it's running. If it's a 3-phase motor, then it's got 3 coils 120 degrees apart from each other, and then it has a rotor in it that's a magnet. And so the energy is just from the generator is reversed in the motor, where instead of it producing electricity, the electricity excites the coil, creating a magnetic field, and then it repels the north and south poles on the motor. And because they're 120 degrees apart from each other, each time one of the coils is excited, it pushes until the rotor hits another spot, in which case then the second phase has already come into play, and then starts repelling it, and it's stepped naturally, so it naturally moves in one direction without you need any capacitors or anything to help it continue to go. You don't even need a start capacitor, because it's because of the way that they're offset. So that's how basic 3-phase works. Now, when you're talking about residential current or AC current, when it comes into your house at home, it goes through what they call a split phase transformer. Okay, and when you get to your house, there is no 3 phases, and most of the time in residential areas, there aren't even 3 phases available. So that's why, you go down the road and you see these high tension power lines, and like when you see those big, huge easements where the highway, you look to the left and there's trees on one side and trees on the other side and just a wide open field in the middle. And then you got these big towers that, they got these three big wires coming off of them, right? Those are the 3 phases of power coming from the power plant and going to the substations to be distributed, and then each phase is sent out into one direction. Like one goes in one side of the city, one goes the other side of the city, and then the other one goes the other side of the city, and and they're that way you get one phase supplying each area. And then you also see the really big lines, the ones that are like the primaries that are actually coming like directly from the power plant. Like some of them come from substations, and they're still big, huge power lines, but they're not the ones that come directly from the power plant. They're subdivided, but the really big ones, you'll see the towers that have 3 lines on them, okay, but then they also they'll have 3 lines on each bundle. You know what I mean? So each of the 3 will have 3 lines on them too. So now this is the thing. These are 3 phases in each one of those lines, right, that are separated. And then there's also, the 3 phases that are on each of the bundles. And the way they do that is, I was talking about earlier, where a generator can produce multiple phases, more than 3. But then when they're rectified, or not rectified, but when they're processed in this, and getting into electrical engineering, that I understand it, but I don't know fully exactly how they do it. But you can take 3 phases and put them on each bundle, and it's just called interlacing. And and then when you get to each like substation or whatever where they're retransmitted or stepped down and then redirected in whatever direction, then you can take these 3 phases on each line, and you can actually supply different sides of town, with 3 phases of power instead of having to, do it in other ways. But ultimately, when you get to in residential areas, which is the most, which is where most power is consumed, is in people's households. All right, you have 1 phase coming in, which is just one of these lines, right? And that phase is split in half. So you'll have the 1 phase, and you just kind of draw a line through it, right? And take that phase and split it in half, and then you get 1 at the top and you get 1 at the bottom. All right, so now you have basically a 0 and 180 on the 1 phase on one side, and then you also have a 0 and 180 on the other side. All right, so you're taking just imagine positive and negative. It's not really, but it's the 0 and 180 of the 1 phase, which 180 is here, 0 is here. And when you get to and I think this might actually be, so what it really is it's over here like this, okay, of the sign, how it's broken down, right? And then so this one right here, okay, and this one right here, okay, would be part of the negative, or the the 180, and part of the 0, okay. So like as the magnet's coming around and reaching, its peak potential at the of the coil, all right, you're going from 0 volts up to 120, and then, or 110, and then to 220. When in reality it's 120 and 240, okay. But when it's halfway through the sign, you're getting 120 volts, and then when it's all the way to the peak of the sign, then you're getting 240 volts, okay. And the same is true for the other side, is that when you're at 90 degrees, you're getting 120, and then you're getting 240 at the peak of the sign. All right, so when you're halfway through either side of the phase, you can now draw the positive from one side and the negative from the other side at the same time. And also, when it reverses, the positive from one side and the negative from the other side, and split it in half, and then you get 120 volts on either side, okay. But then if you wanted to pull the whole thing, that's where you get the whole 240. And the way this works at the transformer is it's got what they call a center tap on it, right? And this is the neutral line, the white wire that comes in, and it's also ground, okay. Either one works. Though I wouldn't, you don't be hooking, your ground wire to, or you don't be hooking your, you don't be hooking. They separate ground and neutral, because obviously ground wires are bare most of the time. Sometimes they're coated green, or they're usually green, and that means green for green earth. And then the white is neutral because it goes to the transformer. But when it goes to the center of the transformer, it is also sent to a ground wire on the pole, which in case you get a short or whatever, it goes to the ground instead of going back into the grid, or back into the house somehow. So that's why. And it's always going to take the path of least resistance which ground is the probably the path of most resistance when it comes to the actual circuit in the grid. But because at the transformer, or I'm sorry, at the generator, it's not grounded. In the sense that it's grounded, but the ground is so fucking far away, you know what I mean, that it can't really, so it just, each power pole actually is grounded. So because each one's grounded and also hooked to the neutral line, if you get a short, in your side over here, then what it's going to do is it's going to go through the ground and it's going to go over to the next pole over to its neutral line. And that's how that works. So anyway, completing the circuit. But then what happens is you get, you got these two, these two things, little rabbit ear looking things coming off the top of the transformer. And that's where you got one hot wire. They're both black, okay, but you got one hot wire and you got another hot wire. They call them the line wire, and not lime, the line wire. And then the one in the center is the neutral wire, okay. And that's when you look at your at the wire coming in from your power pole to your house, or to the outside where you see the little weatherhead and the pipe that's going up on that wooden pole, and you see the lines going in. They look like they're braided or whatever. They're like twisted around each other, okay. And two of them are black and one of them's bare. The two black ones are your line wires, and the bare one is your neutral line. It's also the ground, but it's a hooked to a ground wire, so for all intents and purposes it acts as a ground as well. But anyway, so when you get, and then off the hot wire that's actually coming in from the pole, which is the main line that's coming off the top, and the line anyway, and that's your pole, okay. It's got a separate rabbit ear, whatever coming off that you see a little wire that's hooked to it that goes up to the wire on the pole. All right, now that's just one wire, and again, it doesn't need like a circuit to complete it, or another wire to complete the circuit, because it's flowing back and forth. So it is the return path as well as the supply path. It's the input and the output at the same time, because it's alternating back and forth. But then when it's stepped down to 240 volts in your transformer, okay, it's the same thing as the coil in the generator. It's got one that's going out this way, and it's also got the one going out the other direction, okay. So, and it alternates back and forth. And then the center tap right here, it gives it this center tap is attached to the coil inside the transformer, so that when the voltage is alternating back and forth, it can go like a figure 8 pattern. It can kind of go this way, and then return on the other line, back, or when it's coming out this side of the phase, it can return through the neutral back up this way and complete the circuit, to the other side. And then when it completes the circuit to this side, some of the voltage that's still good goes back out with the other voltage, okay. And then same thing is when you're coming out this side of the phase, okay, it's sent out, and then it returns back on the neutral line, and then is given back to the other side of the phase. So it's this figure 8 pattern, okay. And the thing about split phase is that like especially with electric motors and whatnot, because you have what they call amperage and voltage, and the amperage might be higher than the voltage, but they're in phase with each other, okay. But then once they pass across an inductor, right, which is that is how all the electricity is transmitted when it's stepped up and stepped down by transformers or whatnot, is it's through inductance that is created. So you get your voltage and you get your amperage, right? Sometimes the amperage is higher than the voltage. You have 120 volts and 4 or 5 amps. But then once it goes through the motor, the magnetic field that's created, and then also the because it's being repelled by the magnet that's in the motor, okay, what it does is it distorts the phase. It distorts the alignment of the phase, so that the amperage will start to drop, and the voltage will drop as well. Or sometimes the amperage will increase and the voltage will drop, depending on how much resistance is there, because the voltage is the electromotive force that makes the thing move, but the amperage is the amount of power that has to be put through it in order to allow the voltage to drive it. Okay, so the more resistance that's on it, the more the voltage is going to drop, and then the amperage is going to have to bleed out somehow. It'll either throw it out of alignment, or the amperage will it'll increase, and kind of like store itself in what they call inductance, and then as the rotor turns, what I mean, then it's kind of like opening a valve and letting that current go through. And so the voltage is like dissipated in heat through the resistance, and the amperage is just stored and then dumped out as the gate opens, kind of thing. I think of it like if you're putting your finger over the end of a water hose, and it's like that spray that comes out when the pressure it builds up too much that your finger can't stop it anymore. Well, that spray that comes out would be like heat from the voltage, okay, and then the more you open your thumb up, the more water flows. That's considered the amperage coming out. Even though the spray is amperage as well, it's anyway. I don't know if that makes sense or not, but it's best I can explain it. So, and I'm sure that some of y'all might have got the answer to your question already, but some of y'all might still be having trouble understanding it. But when they convert AC to DC, it goes through what they call a rectifier. And same thing on your car. And all it is just because you have positive, negative on one wire, okay, but then you have positive, negative on 2 wires on direct current that's actually flowing in one direction. Okay, direct current's not going to allow the energy to flow in both directions. So what they do is they put a diode on one side, actually on both sides, and the symbol for a diode looks like this, and it's got a little line on it, and that shows it, whichever way the arrow is pointing is the way the electricity is allowed to flow. So they'll put this polarity diode on one side of the on the line side of the circuit, okay, and then the other diode, which is another polarity diode, will be on the other side of the circuit. So when you even with 240 volts, it's still, when it's alternating back and forth, electricity is only allowed to flow in one direction. And what they'll do is they'll have this side like feeding this side over here, so that current, so when it's flowing this way, okay, it'll let it flow, but then when it comes back the other way, it's blocked right here, and there is no current coming back the other direction, to begin with. And so there's nothing coming through this side, and it's blocked on this side, so it's only allowed to flow in this direction, this way, okay? And then you have the positive, but then you have to have a return path as well. So the return path is between the load, which would be a motor or whatever, and the line, okay, or the neutral in this case, whatever. So just a simple set of diodes there's your rectifier. And I think it's a little more complicated than that, but but that's basically it, you know. So the other thing is, why I'm doing this also is that for those of you who have continued to watch, when if you start understanding this and you know, maybe watch the video again, so that you can fully understand it, in my next video I'm going to show you how this relates to religion and Satan and Lucifer and why evil exists, and you know, etc., etc. And if you know, immediately write me off as a, you know, a lunatic or something like that, let me just show you, and you know what I'm talking about. Go look them up on Google. You'll see those high tension power lines that I was talking about that have the 3 phases of power that's being distributed to the city. Okay, look at the way the towers are shaped. All right, they look like these, you know, they look like these. Well, I'll show you in a second. I'll draw this other one, but that's how these towers are shaped, and there's your 3 phases. Okay, and the tower kind of comes down like this. And then like, kind of, anyway, so it's about the best as I can. I'm not an artist, but anyway, so that's how these high tension power lines look, you know what I mean? And if you look at the pentagram, that, you know, the symbol for Satan is upside down, whatever the hell they call it, an upside down star. These are the horns, you know what I mean, that represent, you know, Satan. And this is his little goatee, right? And these are his goat ears or whatever, right? So anyway, I mean, can you see the resemblance? Go look it up on Google, and you'll see what I'm talking about. I know a lot of you know, and for those of you who do know, and whatever, you know, share that with your friends, because it's you'll see in the next video. I'm gonna get real deep into why. I'm gonna get real deep into why this, you know, this all relates to evil, and why we're here, where we come from, creation, and all this shit. So I hope you enjoyed the video. Hope that explains for y'all. Have a good one.